Chapter 3. In Chapter 3, we do a lot of things that are very critical to the rest of the year in geometry. So the lessons we're going to learn here are very, very important ones, and ones that it's pretty critical that you understand fully as we move ahead and start talking about other things in geometry. So please pay special attention. We're going to learn a lot of different vocabulary terms, especially angle pair names and relationships that are just going to keep coming up all throughout the year. So please make sure you're paying special attention to the lectures in this chapter, as well as paying special attention to the vocabulary and making sure you understand it, know what those words and phrases mean, because it's going to make a difference. We're going to get quite a bit today right off the bat, and we're going to keep using it throughout the chapter. And the first thing we're going to talk about today is parallel. Now, parallel is one of those things that everybody thinks they know what parallel means, because, yeah, fine, we learned parallel lines, railroad tracks, whatever else, that's parallel lines, we're good. Well, yes, and not necessarily yes. We're going to be very specific, like so many things you do in geometry, about what parallel means. So, basically, parallel lines are lines that lie in the same plane that do not intersect. Now, here in the diagram that we have in plane T, we see we have some parallel lines, line M and line N. And now I want you to note in the diagram right away that we have symbols that we're going to use here to indicate the parallelism, these little red triangles on the line. Those triangles are indicating that those lines are parallel. Those are not the same as the tick marks that we use to indicate congruence, because to start with, lines can't be congruent because lines are infinite, but lines can be parallel. And so those little triangles are what we use to indicate parallel lines in a diagram. Two lines that lie in the same plane and do not intersect are parallel. Two lines that lie in different planes, such as line K here and line M, two lines that lie in different planes and do not intersect are not considered parallel. They are considered skew. Right here, lines M and K are skew lines. So just saying two lines that don't intersect is a definition of parallel really isn't sufficient. It's what we've always done in the past, but now we see that there are certain situations where two lines don't intersect where they are not parallel, they are skew. We can also have parallel planes. Parallel planes simply don't intersect. Here, T and U were given that they are parallel planes. We also have intersecting lines. So like N and K are intersecting lines. We can have lines intersecting a plane. We can have a line parallel to a plane, all sorts of things like that. Again, symbol-wise, the symbol here, parallel to. The two parallel lines indicates parallelism, so we see it written like M is parallel to N. Understand the symbols, understand the way things are written. That makes you literate in what's going on in the geometry here. So all sorts of things about parallel lines. Now, once we get the vocabulary down, it's really not that difficult. And a great model for parallel and skew lines is simply a box. A box is an awesome model for parallel lines and skew lines, because in a plain old box, we've got all these right angles going on, we've got all these lines, all these sides, and we can go ahead and start talking about what's parallel to what, and what's skew to what, and what does that mean to be parallel or to be skew. So, what it wants us to do here, lines parallel to CD and containing point A. All right, so on a line parallel to CD, let's find that. CD is right here, and containing point A, which is right here. So what lines could I draw parallel to CD and containing point A? Well, it's pretty clear right away. I could probably get line AB. And again, I'm using the correct symbol because it asks me to name a line or lines that contain point A that are parallel to CD. So AB is our parallel line. And are there any others parallel that contain point A? Well, let's see. What other lines contain point A? AG wouldn't be parallel. It would intersect it. That would be skew. AD would be intersecting. That's fine. AH, as we look down here, again, AH would not intersect line CD, but it would not be a parallel line because it's not in the same plane, so that would be considered skew. So, again, I'm pretty sure AB is pretty much our only one containing point A that would be parallel to CD. What about lines skew to CD containing point A? Oh, well, this gives us a few more options, doesn't it? In fact, there's probably a whole lot of options here. So let's see what we got here. AG as a line does not intersect DC, but is not in the same plane, so AG would be a skew line. AH does not lie in the same plane, does not intersect, so that would be skew. AB we've already covered. So as far as lines that are drawn in here, AD we know is intersecting. It's in the same plane. But I could draw more lines. There's AE would be a line. Any 2 points make a line, we know that. So AE would be a line that doesn't intersect. Same with AF. In the plane does not intersect. So we have a lot of skew lines here, don't we? A whole lot of skew lines. So something to keep in mind that we can get a lot of lines here and that we don't necessarily have to have those lines drawn in the picture in order for them to be lines. Lines perpendicular to CD containing point A, that's pretty straightforward. That's AD. And that would appear to be the only one. That's the only one that contains point A that would be perpendicular. Any other line containing point A would not be a right angle, so that's the only one. And planes parallel to plane EFG containing point A. So where's plane EFG is this one down here. Okay, that's the bottom plane. So containing point A, the parallel plane would be the top plane of the box. And again, so I could say plane, and I need 3 letters, 3 points that are not all in the same line in that plane. So I'll go with ABC. I could go ABD, ACD, however you like. Any of those would work. So there we go, identifying some parallel lines. Now, I want you to notice something. How many parallel lines do we get containing point A? Just one. How many perpendicular lines containing point A? Just one. How many skew lines? A whole lot. And if I put more points in, I could get about a bunch more. This leads us to our idea of our parallel and our perpendicular postulate. The parallel postulate says, given a line and a point not on that line, there is exactly one line through the point parallel to the given line. Great illustration here. We got a line L. Highlighter out, got the line L. We got a point P not on the line L. How many lines can I draw through point P so that the new line is parallel to the original line? Just one. Exactly one. No more than one. Exactly one. Same thing with perpendicular. The exact same situation. I got the line L. I got the line point P not on L. How many lines can I draw through P so that the new line is perpendicular to the original line? Just one. What did we see? How many lines were there parallel to a given line, in a given point? We had one. How many lines perpendicular to a given line containing a certain point? Just one. So we already demonstrated that. And that's pretty important. Those are the postulates we're going to be using for parallel and perpendicular. Now, let me be clear, there are other types of geometries that have other types of parallel postulates. Spherical geometry, limited geometries, circular geometries. There's all sorts of things that you can do that by altering the parallel postulate or altering the type of surface we're working on completely changes how we evaluate things. For example, spherical geometry is an easy one to think about because we live on a sphere. I mean, our planet is roughly a sphere. And the geometry there, things are not flat planes. They are spherical. So the postulates are different on a sphere than they are on a plane. We're working in plane geometry. And that's what this whole course is. You want to work on spherical geometry and stuff like that, I'm sure you can find some online sources. Or you could take a course on it in college. That would be great. And some of your homework today is going to be simple stuff like this. Name a parallel lines. Again, what we're going to look for here are little triangles. I guess yellow wasn't the best color. Let's use blue. That makes green. Fun. Yellow and blue make green. How about that? But notice the indication there that line DM is parallel to line EF, according to the indications there. So that's important to notice that that's as being indicated. Some of you may want to go with line FB and line CE, but we really don't have the facts to necessarily conclude that those lines are parallel. It looks like they are, but I need facts. And the little indications, marks there, are the facts. Perpendicular lines, the only perpendicular lines, according to the facts we have, because the only right angle symbol is right there, would be line BF and line DA. Those are our perpendicular lines. And it asks, is FE parallel to AC? FE and AC, are they parallel lines? Well, when I look at that, it's a little bit interesting. Let's pick a different color highlighter for a second here. Let's go with an orange highlighter. That might be interesting. All right. So FE and AC, are they parallel lines? Well, according to the picture, they don't intersect. We don't see them intersecting, but common sense tells us that, yeah, they're going to intersect probably if we just extend them a little bit more. Boom, we're going to get a point of intersection. So just because they aren't drawn intersecting doesn't mean they don't intersect. Because lines are infinite. They go on forever. All right, so that's parallel, perpendicular, and skew. That's our first big vocabulary thing today. This is our second, and it's going to be naming angle pairs. We've already got linear pair. We've already got vertical angles. We've already got all those different things. Now we're going to get some different angle pairs that occur when two lines are crossed by a third line. So I have two lines, line 1 and 2 here, are being crossed by a third line, T. We call this line crossing the first two lines a transversal. And sometimes say crossed by a transversal, we say it's cut by a transversal. That's not so important. But what that does is that creates two intersections, essentially. And when we see those two intersections, when I have two lines being crossed by a third line, I get two intersections. And that forms 8 angles. 1, 2, 3, 4, 5, 6, 7, and 8. Okay? 8 angles are shown. And what we're going to do is we're going to start naming specific pairs of angles, one from each intersection. So these angle pairs all choose one angle from each intersection and then give a name to that angle pair. Tomorrow we'll start talking about the relationships if the lines are parallel. Excuse me. I want to go back. So first one is called corresponding angles. Corresponding angles are named as such because they're in the same corresponding position, both upper right, both lower left, both upper left, both lower right, or whatever. So 2 and 6 here are an example of corresponding angles. They'd both be the upper right angles. Those are called corresponding angles. Now, it's another one that we're going to get a lot of words that begin with the letter C: corresponding, congruent, consecutive, interior. That's going to be coming up in just a second. We already have complementary. So we got to work on our vocabulary here. Make sure we understand it. The next name, alternate interior angles. Again, this is an example of a descriptive name. Interior, when two lines intersect like this, or when two lines are crossed by a transversal, the area between the two lines is referred to as the interior, and which means the area not between is referred to as the exterior. So alternate interior angles, both angles are interior, and they are on alternate sides of the transversal. So 4 and 5 would be an alternate interior pair. Also, these two angles here would be considered an alternate interior pair. Okay? Alternate exterior angles, same basic idea. This time, one from each intersection on the exterior and on alternate sides of transversal 1 and 8. Or alternate exterior, as are the two angles indicated by the double dots there. Last angle pair are called consecutive interior angles. So if they're not alternate side, they're on they're consecutive angles. They're next to each other. So consecutive. They aren't adjacent, but they're consecutive. So 3 and 5 would be considered here consecutive interior, as well as these two angles on the other side are consecutive interior. You probably want to make flashcards with pictures and names describing what's going on, because these are terms you definitely need to know, and you might want to quiz yourself with these flashcards. So that might be something you want to pause the podcast and go and make the flashcards and do that. Identify all pairs of the given type. We've rearranged the numbers. We've rearranged the formats. Let's identify the corresponding angles. So A, corresponding pairs. Well, corresponding is same corresponding position. Pick one, angle 1. What's the corresponding position? That's in the upper left. Upper left is angle 5. So angle 1 and angle 5. Angle 2 goes with angle 6. Angle 3 goes with, angle 3 and angle 7. And finally, angle 4 and angle 8. Those are my corresponding pairs. Alternate interior pairs. Okay, we aren't going to be able to pick any old angle to start with this time. It's got to be interior. So the interior is this section right here. So if that's my interior, pick one interior angle. 2, the alternate interior one. Well, it's not 4 because 2 and 4 are a linear pair and they're at the same intersection. It has to be an alternate sides of transversal, so it has to be angle 2 and angle 7 in this picture. Or, instead of 2 and 7, we could also go with 5 and 4. Alternate exterior, same basic criteria, angle 1 and angle 8, angle 3 and angle 6 in this picture. And finally, consecutive interiors are 2 and 5, and 4 and 7. Now, not all pairs of angles have a name. We clearly have linear pairs here. We clearly have vertical angles. 1 and 2 are linear pair, 2 and 4, 3 and 4, 1 and 3. Those are all linear pairs. Vertical pairs would be like 1 and 4 or 3 and 2. Okay, so we've got those things going on. But not every pair of angles is going to have a name. For example, if I chose 1 and 7, there's no name for that angle pair. So not every pair of angles is going to have some sort of name in relationship, but that's okay. Classify the numbered pair of angles. So again, we look at this and say, okay, what name is associated? 1 and 5. Well, I look at that. 5 is interior, 1 is exterior. So it's not consecutive interior, not alternate exterior, not alternate exterior. They're both in the upper left corner. That's corresponding. Here, 2 and 7, I do notice that they are both exteriors, and they're on different sides of the transversal, so alternate exterior. 5 and 4, in case you're wondering, they're indicating these angles right here, are 5 and 4. Again, they're both interior and they are not on the same side of the transversal. They're on alternate sides, so alternate exterior. So you'll have some work today or tomorrow dealing with naming these angle pairs and identifying them. It is very important that you're able to accurately name and identify angle pairs. That's going to not stop all year long. We'll see you in class.